Uh, Hi, for the YouTube video today I'm going to discuss about microservices architecture, a simple project. You can consider it as an academic project also. You can see we're going to create two microservices. One is student microservices, other thing is school microservices. So we will create an API gateway. Initially the request comes to the API gateway. From there it will be routed to either students endpoint or school's endpoint. You can see this here, and we will create a separate Docker image for each service, and then we also configure the distributed logging using Zipkin. For this project you can see Zipkin, we are using a Zipkin here in the architecture diagram. And also you can see we need to create a discovery server, Eureka server, using a Spring Cloud Eureka server, so by which we can actually register all these microservices as a client, so that we can simply discovery servers on fly. It will identify the service instance address, and we can use it for establishing a proper communication. Dynamically the communication will be established. I will explain the code, how it will work. And config server is this server, so we need to push the properties into separate third-party server, and from there we can actually pull the properties, right? So in real time, we consider it, we use config server. We do not store the properties inside the project code base or inside local or somewhere else, because it is not recommended. You will store the all properties in some third-party server, secure server, and you will pull these configuration properties when application is getting deployed. So this is a high-level architecture. You can see it. Now I'm going to explain the code one by one. Let's see it very carefully. So API gateway is the initial service where the request will come to the API gateway, and the API gateway will redirect and route all these requests to the corresponding endpoint microservice. And the config server, as I told you, it will centralize all the configuration properties. It will store all the properties of microservices required, and that way we use the configuration. And you can see the discovery server is a Eureka server, so it provides a service registration and discovery, enabling seamless service to service communication within the microservices ecosystem. Okay, you will understand this. And we have two microservices. One thing, student microservices. Student microservice is responsible for managing student related data and operations, adding, updating, retrieving student records. School microservices manages the school related data operations, including adding, updating, and retrieving all CRUD operations. And we use the Fin client for inter-service communications. As I told you, we want to call a student microservice from the school service. So how do we do that? We use the Fin client, because we create a Fin client interface, and then we can auto write that interface in a school service. We can actually call the student microservice for data, for inter service communication, you see. And distributed tracing using a Zipkin. So if you are talking about microservice based architecture, you should use a distributed tracing, and Zipkin is one of the best framework for providing the distributed logging and tracing features. So see, observability and visualization, enabling visualization, everything is there. And now first thing, we are going to create a student service. So you can see the POM data. We are using actually Maven build tool here. You can see Maven build tool. Group ID is net.java guides, and artifact is student, you can see. And we need to include these starter dependencies, Spring Boot starter actuator, Spring Boot, starter data JPA, starter web. If you want to starter JPA because you want to use a JPA, right? Java Persistent API, and starter actuators are required, and PostgreSQL we are using. We need to include the PostgreSQL as well. And our Lambak is also a dependency. We actually use shortcut annotations for entities and POSO. I'll explain that later. And also we are using a starter test dependency. Okay. So now you see this is a simple form.xml. Now we need to create a PostgreSQL database. You see what we are doing, we are actually in application.yaml file. We need to provide a driver card, all the driver details, data source details. You can see here what is this driver class name, JDBC URL, username, password, and you can see. And we are also using Hibernate for implementation of the JPA. So what we are doing here, we are actually enabling a DDL auto, and database is a PostgreSQL, and database platform. You can see that dialect is Hibernate dialect, Postgres dialect we are using because we are connecting to the Postgres database. Okay, so this is what it is. So, and after that we need to create a JPA entity. So you can see, and here you can see the usage of Lambak. You can see how the Lambak is used. We can actually enable, you can enable setter, getters, all the entity details. So we are using @entity annotation, @getter, @setter, @allogs constructor, @noargs constructor, @builder. Builder design pattern is a very good design pattern. See, we did not specify any setter and getter. See, we just specified all the properties and we marked this entity using annotations, right? It is simple. That way you can actually avoid the boilerplate coding. You don't need to do that. You can see all the things here, how simply we created a POSO. It is entity, so we marked with the @entity, @getter, @setter, @allogs constructor, no constructor. Allog constructor means every entity should have if we are creating a all argument constructor, no argument constructor, default constructor. By default it will be there, and builder pattern is there. Builder pattern, so if you want to set any values, right, you can simply set the value. So it will provide you. I will explain where we use the builder pattern. @getter, @setter, they'll enable the getter and setter methods. And you can see we need to create a student repository. And what we are doing here, we need to import the JPA repository, repository. A student repository extends the JPA repository, and JPA repository is taking the arguments in student entity and integer data type. So there is one method declared inside this student repository, find all by school ID, and which is returning of type list of students. Okay, and it is taking a school ID as a parameter. So JPA repository, using JPA repository, it provides underlining implementation for all the methods, default methods. So you can simply access the database using get data, put data, delete data. These data, these base underlining implementations will be there under JPA repository. That is why we are extending this. And you can see service layer. And now it is very simple. You want to interact with the database, right? You want to interact with the database. JPA in repository will provide you all these methods, so that you can actually talk to the DB and you can update the DB. You can manipulate the database, whatever you want to do it. So you are doing it through entity. You can see you are actually your entity. You are actually mapping the database tables to your entity through JPA repository. You can see here. That is why we need it. And service layer, student service, and this is the service layer. So we need to mark this class using @service annotation and @required arg constructor. we marked this. Okay, and you can see we are actually auto-void the repository. So we did not use any @auto-void because we used @required our constructor. That way this student repository will be auto-void, automatically the dependency will be auto-void. And you see we are actually using save student, find all students by school. Okay, there are three methods basically here, and this is the service for students controller, and we need to create a student controller. As I explained you, we are actually using the bean dependency of repository service, student repository service, right? So you need to understand that. And now we have to auto-wire this service into controller. Where is our controller? Here is our controller. You can see we mark this controller using @REST controller, @request mapping, and we are giving some endpoint details. So whenever you are calling any URI method inside this particular control, you need to give the complete mapping address, like if it is localhost 8080/API/v1/students and your method URL. So that way you need to suppose get mapping URL is there, so you need to provide that complete mapping, because we specified the @request mapping details and required our constructor for auto-wiring the student service. And now we are auto-wired the student service. You can see here what we are doing. We have a save method, post mapping. We need to mark it as @post mapping, and the response status is a HTTP status dot created. So it will return once we insert any student data. After that it will return HTTP status with the created details. Okay, and we are saving the data. And there is a get mapping method. We are getting all the list of students here, find all students, and the response entity dot OK. You can see we are returning all the find all students. Okay, and then we need to get a school data using a school ID. There will be multiple schools, so every school will have a school ID. So what it will do, we created a method, find all students method. It is taking you see it is taking a school ID as a parameter, and we are giving the school ID as a path variable, not as a request parameter. Okay, you need to remember that. And we are returning the data by passing a school ID. And now create a school microservice. Okay, sorry, this is a student controller, right? It is so far I explained it is a student controller, student information. Now we need to create a school microservice. Okay, so far we discussed about the school student controller, student service, all these details. Okay, so that is the one thing. So now we are going to create a school microservice in the same way. Here you need to understand one thing. Why did we create a why did we give this passing a school ID? Okay, student microservice is having a get one method where we need to pass the school ID. Based on the school ID, it will fetch all the student information. So that is why we have given endpoint /school/ like that. Okay, that is fine. Now we'll go to the school microservice. School microservice, what are the dependencies we required? Again, we need to provide the group ID, artifact ID, version, and you can see we need to we are using Java version 17. Okay, you need to mark this because we are using a Java version 17. It's not a 16, it's not a 18, it's a 17. We are using 17. We need to remember that. And we are also using a actuator. We need to use the starter actuators, JPA, starters and web starters. We require them because we will generate a jar file. We require the starter web dependency and Postgres dependency, Lombok dependency, and if we write any test cases, so we need a starter test dependency as well. So these are very common. So Lombok also a common plugin, I told you, right? So Lombok would be useful for creating entities by using annotations. We don't need to create a setter, getters, constructors. So we can avoid boilerplate coding. We can actually create an entity as simple as possible. For this also we need to provide the data source details. Okay, we are providing all data source details. We need to include the Hibernate dialect and database is Postgres and DDL auto create. It means, so what it will do, it will every time it will create the schema, DB schema. When you instantiate an application, you need to remember that. Okay, and you can see school JPA entity. What is the school JPA entity is containing? School ID, school name, email. These are the details. And interface, school repository, JPA repository, you need to create it. And inside this we did not specify any methods. You need to understand here, because as I told you, JPA repository itself will have all the inbuilt methods, predefined methods. You can use them to fetch the data and to update the data. Now you can see school, we need to create a DTO, because DTOs are useful when you want to get a customized response. Sometimes you may get 100 attributes, so you don't need 100 attributes to render as a response. You may require only 3 attributes. Then you simply create a DTO. You can set all the return response only for specific 3 attributes or 10 attributes or 20 attributes. It depends on your requirement. Okay, and after that you see, and we need to create a school service. So we're going to auto wire 2 things here. We're going to auto wire school repository interface, and we need to auto wire the student client. What is the student client here? Student client is a fin client interface, because we created an interface marking with the fin client. As I told you, we want to interact, we want to establish inter-service communication from the school microservice to student microservice. I want to get the students data for each school, right? So the school can have there will be multiple schools, and for each school there will be certain number of students. So every school will have an ID. Let's say if I want to get the some CBSE school, central CBSE school is there. I want to get the number of students who are studying in a CBSE school. I'll pass the ID as 18 or something, and it will fetch all the details. Okay, so that way I want to establish a command and I want to get the data. And public void save school, see, save method is there, and find all schools method is there. Okay, this is a simple school service. And you can see here we need to create a controller. As usual, we need to mark this controller using a REST controller, request mapping, request arg constructor, because you can see the service class we did not specify annotation, auto void annotation. So we simply specified private final school service space service object. It will actually auto wire because we used annotation required arg constructor. That will do the magic there. Okay, and we have a save method, and we have find all schools. You can see all these things here. There are 2 methods, post mapping and get mapping, as usual. And so okay, here I'm going to explain the things how we are going to establish a inter-service communication between school service and the student service. First thing is you need to add a dependency, starter dependency for open fin client. You need to add this, and you can see I'm going to add this. So in this project they added this fin client. Where is this fin client? You need to add here. somewhere. So here we added it, you can see it here. Spring Cloud Starter Open Fin Client. So now I will show you how we can establish a communication from school service to student service. So first thing is you need to create a interface, student client interface, by marking that interface using @fin client annotation. You need to provide the name of the service and you need to specify the URL configuration for that particular service. So here we are reading, you can see we are reading this properties from the configuration file. Okay, so $braces application.config student URL. You might have specified this application.config student URL in application.yaml file, application.properties file or YAML file, and it will read that particular URL here. So we are just providing a interface here. Okay, what we are doing using a fin client here, we are simply creating some interface object for this particular endpoint URL, so that I can simply create an object for this interface and I can use this particular endpoint URL for establishing a communication. So this piece of code we need to add in this service. I'll explain what we do. So you can see this is a school service class, and now we need to auto-wire. We are going to auto-wire student client here. You can see we used @request or constructor. Okay, you can say I'm going to explain each and everything, the code that is specified here, so that you will be able to understand what exactly is happening with this code base. So now you see there is a method find schools with students. Okay, and it is taking the school ID. So the user will send a school ID and it will render the school response. Okay, it has to find the list of schools for that particular school ID. Okay, so here we are going to var school equal to repository find by the school ID. Okay, we use some Java 8 functional programming style here. You can see, or else we used a builder pattern, school.builder. In else case, if the school is not found by particular ID, what we are doing, we used a builder pattern. We are not setting the values. We are not using any setters and getters. That is the benefit of the builder pattern. You can simply set the values like this: builder.name not found, .email not found, .build. It will build that POJO and it will render the response automatically. That is why we use the builder pattern. I told you, right, why we use this @builder annotation. This is the purpose of builder annotation. So you can simply set the properties for any entity using a builder pattern. Even if you don't require the setter and getters, all these things, you don't require the setter methods, you can simply do like this. And after that, see var students variable, and you can see we are using client dot find all students by school, passing school ID. What is the client here? Client is the object of student client, fin client interface, right? It is the interface which is marked with the fin client annotation. So that way we are simply, we are actually not referring any underlining endpoint details here. We don't know what is the local host, what is the actual service endpoint URL. We are not bothering about all these things. We are simply calling this method. You can see it is very simple, straightforward. Okay, and it is returning a school response. And here also we used a builder pattern. You can see builder.name. Okay, and what it is doing, it is simply returning .name, school.getName. Okay, we got some data. Where is this data? We passed the school ID. Initially we have some school data and we are setting all the school data to the response. Got it, right? That way you need to do it. Okay, you need to do that way. And next thing, we create REST API. You can see REST API. What we are doing here, retrieve students by school ID. So you need to create a interface. So you need to create a method. This is the method you need to create. So go to here. Where is it? School controller. There is a save method. There is a get mapping method. Find all school details. There is a get mapping method with the students and school ID. You are passing the school ID. Find all student by school ID. So this is what we are doing here. Okay, find all students with the school ID. For each school we are getting number of students that are studying that particular school. That is the actual use case of this project. Okay, and you can see the discovery server, Spring Cloud, Netflix, Eureka for service register and discovery. So there is this Spring Cloud Netflix Eureka dependency is available. You can simply create a Eureka server. I told you why we use the Eureka server, because we need a Eureka server for finding the instance of the particular services. So you don't need to hard code any service endpoint details. You can simply use Eureka server. You can register all your services to Eureka server. That way Eureka server will dynamically find that particular service. Okay, so sometimes you can also instantiate multiple services, multiple instances for single service. So then that time you don't need to deploy the services with the different port options, right? You can deploy with the different port options, but when the request is coming, right, automatically the Eureka server, what it will do, it will reroute this particular request to corresponding instance. If you configure the load balancer, that will automatically distribute the load multiple instances. So that way we will do it here. And you can see we are going to configure the Eureka server in YAML file, application.yaml file. You can see here Eureka instance ID, register with Eureka false. Initially you need to understand one thing. When we are creating Eureka server, this is a server, this is not a service, right? So that is why we need to specify the register with Eureka as a false. We need to mark it as a false. Okay, if you are registering a service, you need to mark it as a true, but it is a server, right? We need to mark it as a false, because the server cannot be a service, right? So that is why we need to mark the things like this. Now registering the student microservice. Now you see how we are going to register this particular student service. I'll explain you. And we need to include this Spring Cloud Starter Netflix Eureka client dependency. Okay, and after that, so what you are going to do here is registering a school microservice with Eureka client. So we need to include the client dependency here, not the server dependency. Earlier for Eureka server we included this particular server dependency, but here we are including client dependency. And see how we are going to register this particular service. You can see here Eureka instance host name is localhost, client service URL. You need to specify the Eureka server URL here. Okay, that way this particular service will be registered with the discovery service. You can see after registering it, you can see the application name and the URL, what is the particular URL that is it registered, and the port details also you can see. And API gateway. Okay, API gateway, as I told you, API gateway is the entry point microservice. You know, for whenever the client request is coming, this is the first microservice that actually receives the request. Okay, that receives the request, and then it will route the request based on the URI. It may route the request to the student service, or it may route the request to the school service. Okay, so for this you need to include the dependency API gateway. API gateway starter dependency is there. You need to include this Eureka client dependency as well. Okay, I'll see the code, and you see here API gateway You need to register this API gateway also for Eureka. So you can see here, and the routing mechanism, you can see how we configure the routing mechanism. The main purpose of Spring API gateway is to configure the routing mechanism, and you can also configure the security. You can authentication and authorization server. I think that is out of the scope of this project. I'm not explaining it. So you see, cloud gateway discovery locator enabled equal to true. We marked it as a true. That means what is happening here? Here we are actually specifying this routing request for this particular student service and this particular school service, and whenever the request is coming, based on the routing predicate, you can see the predicates. What it will do, if the request is coming /API/v1/students, then the request will be routed to the http://localhost 8090 endpoint, because that's what the routing here will do. And if the URI, if the client triggers the URI like /API/v1/schools, then the request will go to the endpoint with the port number 8070. It is simple. Okay, so this is all about the API gateway. And the configuration server, we need to create a config server also, right? Let me explain. The config server, you need to include the Spring Cloud config server dependency. This is dependencies you need to remember. If it is a client, it will be a config client. If it is a server, it will be a config server. Okay, these things are we need to remember, and we need to use the @enable config server config annotations. Okay, you're getting it right. So that is what we need to do. So we created this server, and server port 8884, so 8888 you can call it. Okay, 8888, and the server name is config server, application name, and the cloud config server native configurations. So if any configurations are there, it will pick from there. Okay, you see students YAML file. So we need to for the student service, you go to the students YAML file. In the students YAML file, you need to configure this service URL. What is this service URL? Eureka service URL is there, and data source details are there, and management tracing sampling probability 1.0. This is the actuator related concept for tracing related. Okay, you can actually monitor health and metrics. So folder keep all configurations. See what we are doing here. We created a config server. We need to place all these configuration files under /resources/configuration folder. What we are doing, because this is a remote server, right? So we want to store all our property files in a remote server location, that is config server. So in general, we can actually place these properties somewhere in the server location. In production, we will do like this. We do not actually store these YAML files under resources folder of the config server. That is not a recommended approach. I'm not explaining, that is out of the project scope now. So you do remember. So in production, generally we store these files somewhere in some location. Okay, when our config server, inside the config server, we have to make sure we need to provide the specific path of the folder where all these property files are placed. So that way this config server will pick all these files and it will load the data. That is the recommended approach. Okay, that is the recommended approach. You can see all these things here, and discovery.xml file, service discovery. I explained you this, right? It is running on server port 8761, and the gateway is the main thing. It is 8222, and so all these are the, you need to space all these files in, actually you can place all these files in config server, because when you instantiate, when you run the application, all these properties will be loaded there. The config server will pull all this information into the project application, and wherever the properties are required, and application will read these properties. Okay. So just refactoring the code. That is the high level explanation of all this project, and you can see how we are doing. So here, for example, you see we are passing, we want to get all these schools details. Okay, initially we want to post a school information. First we are going to give a school to and email ID, so it will insert the data. A few records are inserted. Okay, if I want to get the data, so it will render the data like this. So that's how we do this. So I hope you understood this, because I explained all concepts: API gateway, cloud config server, Eureka server, and how two services can communicate, how we can establish a inter-service communication. All these things I explained you, and also how it actually read the properties from the remote server. You can see all these things here. Okay. So I hope this would be useful for you. Thank you for listening. Thank you all.